So last time we saw this talking about substituting values in and finding their outputs. And so this time what we're trying to do is to plug in the functions to see what we get. So if I look at this as f of g of x, I know that I'm substituting in for g of x what I have over here for g of x. So what I'm really looking at is f of 2x plus 3. So every place I have an x, notice how I'm just boxing the x and not the x squared, I'm going to substitute that in. So what I'm seeing is 2x plus 3 squared plus 3 times 2x plus 3 minus 1. So now if I combine like terms and multiply out, I get 4x squared plus 12x plus 9 plus 6x plus 9 minus 1. And then I can combine like terms to get 4x squared, combine my x's to be 18x, and then add 9, and then take away 1, so I get plus 17. So this is my f of g of x once I've substituted in the g of x for 2x plus 3. So take a second and do the other one, and then we'll check your work. So did you get your g of f of x to be 2x squared plus 6x plus 1? Hopefully. Okay, so when we talk about finding the domain, what we're looking for is first if there are any kind of restrictions on either of these pieces. So I know that f of x, I need to look at this fraction. When my denominator equals 0, we have a problem. So x plus 2 is not allowed to be equal to 0. So that tells me that x is not allowed to equal negative 2. So automatically, if I get a value of negative 2 that gets substituted in here, I know it's not part of my domain. And then the same thing for g of x. I know that x minus 1 cannot be 0 because it's going to cause the denominator to be 0, which would make it undefined. So I know that x cannot equal 1. So when we go through and figure out what f of g of x is, I need to take g of x, which is this entire thing here, and substitute it in for just the x. So I'm going to do that, and then we'll have to see what it looks like. So I know that I have 4 over, then I have, we're going into f, excuse me. So I have 1 over the x is 4 over x minus 1 plus 2. Now looking at that already, you can tell that you know that x is not supposed to equal 1, because if it does, then this fraction is going to have a 0, and then it's undefined. So what I'm going to do now is combine this, make it all pretty so I don't have a fraction and a fraction, and then look to see what the domain is going to be. So to do that, I know that I need to multiply this 2 by x minus 1 over x minus 1 so I can get a common denominator. So when I do that, the 1 is over 4 plus 2 times x minus 1 all over x minus 1. And I know that if I have a fraction in the denominator, what I'm really doing is multiplying by the reciprocal. So what I'm really looking at is x minus 1 over 4 plus, and I'm just going to go ahead and multiply that out, 2x minus 2. Now again, how I got that was I knew this was 1 over 1, and I'm multiplying by the reciprocal of this. So I knew that it just flipped over, and now I can combine like terms. So I get x minus 1 over 2 plus 2x. Now looking at this, this is my new f of g of x. However, we have to look to make sure that there's no restrictions here. So again, I have to look at the denominator. So is there a place where 2 plus 2x equals 0? Well, if I have 2x cannot equal negative 2, so x cannot equal negative 1. So I actually have 2 restrictions I have to keep in mind with my final answer. So my final answer, we have the f of g of x, and when we look at the domain, your book is probably going to want this funny looking thing. So it's a squiggly bracket x, a bar, such that x does not equal 1, and x does not equal negative 1. Another way to think about it is just that the domain is that x can't be 1, because that's what we found out originally. And then we also know that x cannot equal negative 1, because that's what we found out once we combined the two together. Okay, so on the next page, go ahead and try this one on your own. It's the same two functions, however, we're finding f of x. So take a second to figure out, first of all, what are your domains of the original functions that we have, and then compose the two functions. So pause this video and do that. All right, so take a look at this. Did you get the same thing? If not, go ahead and take a look and try to compare yours to see what you did and what I did and how they're different. Okay, so the next thing we're going to talk about is showing that two composite functions are in fact equal. So that they're the same thing, one's just the inverse of the other, and so we're going to talk about inverse functions a little bit later. But if I have my two functions, f of x and g of x, we want to show that when I do f of g of x and g of f of x, that we get the same thing. So what this is asking for is that f of g of x needs to equal g of f of x, and both of those need to equal just x. So go ahead and see what you get. You can do that on your own and then double check your work. So go ahead and pause the video and try it. So did you get the same thing? When you substituted in g of x, did you get x? Make sure the order of operations are important. You could have distributed this out, then multiplied by 3, it would still undo each other, and then we were just left with x. And over here, we could have distributed this out to everything, those would have still gone away, and we would have just been left with x. Okay, so the last few things that we're going to talk about are a calculus application. So in calculus, sometimes it requires us to be able to figure out what the two components are of the functions. So if I have this function, capital H of x is equal to the square root of x plus 1, that's actually the composition of two things. I have that the square root of x, right? We can see that we have the square root of something, so there's the square root, and then I have x plus 1. So I have x plus 1, and that's what I substituted in for that x here, and I was able to get that. So you can actually see and be able to pick out what some of these functions are. So looking at these, we have a function f of g of x equals our capital H of x. So if I have something like x squared plus 1 to the 50th power, we could easily come up with an option. So I can think right away that maybe this is what I substituted in. So perhaps, remember, f of g of x is written this way. So g of x is what we're substituting into f of x. So I could think about that f of x is maybe x to the 50th power, right? Because that's what could go in here, would be something to the 50th. And what I'm substituting in would be g of x, and that would be x squared plus 1. So to me, that seems kind of like the obvious choice, but there are other options. So I'm just going to move this over here. So if I had thought about it maybe a little bit of a different way, maybe I looked at this and saw f of x was equal to x squared. Well, what would I have to substitute in for x in order to get something to the 50th power? Well, g of x could then be x squared plus 1 to the 25. So we can actually see that work. So if I substitute all of this in there, I get x squared plus 1 to the 25th power all squared. And so if I'm squaring this, we know that these things get multiplied, so I'm left with x squared plus 1 to the 50th power, and that's exactly what we had to begin with. So just another way to think about it, there's not always one answer, there's usually one obvious answer, but not always just one answer. So for this last one, f of g of x, so if I thought about it like this, I know that g of x was substituted in. I see a fraction. Right away, it jumps out to me that f of x would be 1 over x, and then what I'm substituting in must be what's in the denominator, so that would just be x plus 1. So if I take this and substitute in, sure enough, I get 1 over x plus 1. And then the last thing here is just to talk about a word problem in terms of taxes. It's just a way to look at functions like this in the real world. So go ahead, take a second and read it, and then see if you can set up at least one of the equations. Okay, so I went ahead and highlighted a few things that jumped out at me. So I know that I'm making $15 an hour, and we're writing a function g in terms of h. So gross salary, if you think about finance, is how much you make before taxes. Net salary is after taxes. So gross salary is hours worked. Pretty straightforward that my gross salary I take home is $15 per hour. Now, if I want to figure out my net salary, I know that my employer is withholding 20% of my gross salary. So if I think about net, so if I think about my net salary, that would be however much I make, which would be $15 an hour, but we're going to write it in terms of G because that's what it's asking me to do. So my however much I make, which is my gross salary, but I'm being withheld 20% of that. So I'm going to take away 20% of that money, because 20% is my taxes of however much I made. So really what I'm netting is just 80% or 0.8 of my gross. So this here is looking at our net salary of how much we made, and this tells us how much we're making just per hour. So when it comes to finding and interpreting n of g of h, right, because we're using h, I'm going to take this value and substitute it in here. So my net would actually be, so n of g of h is equal to 0.8 times 15h. So if I do that math, 80% of 15 is 12. I get 12h. Now what is that actually meaning? So I found it. I found what n of g of h was, but what does that mean? Instead of making $15 an hour, I'm only making $12 an hour. So our net income is $12 an hour after those taxes, which isn't bad, but it's not great. So now you can think about if you have a minimum wage job, Texas just increased it to $15 an hour. After you take taxes, which aren't always 20%, you're really only taking home $12 an hour. So are you able to live on that? All right, so now you're able to do the rest of your homework, and I will see you all next week.